In late 2015, doctors in maternity wards in the northeastern part of Brazil started seeing an increase in the number of babies born with much smaller heads, a condition known as microcephaly. Microcephaly can be caused by different genetic disorders, certain drugs, and infections, so it's not uncommon for a doctor to see a case every so often. But all of a sudden, doctors in this part of Brazil were seeing babies with microcephaly around 20 times more often. What we now know is that this rise in cases of microcephaly was caused by Zika.
Zika is a virus that's mostly transmitted by mosquitoes, and the virus had shown up in Brazil earlier that year. People infected often had a rash, bloodshot eyes, fever, headache, and joint pain. Most cases, though, passed pretty quickly and were mild. But then babies started being born with smaller heads and devastating brain defects. On February 1st, 2016, the World Health Organization declared the Zika virus epidemic a public health emergency. And in the following months, dozens more countries reported cases of Zika and microcephaly.
I remember hearing about this virus and its spread all the time throughout 2016 and even into 2017. But then I just didn't hear about it all that much. So, what happened to Zika? Welcome to Tiny Matters. I'm Sam Jones, and I'm joined by my co-host, Deboki Chakravarti. Compared to 2015 or 2016, cases of Zika have gone down a lot. And we'll talk a bit about why scientists think that is later in the episode. But Zika is still out there, and it's still dangerous. And thousands of children and their families continue to be impacted by the devastating effects of the virus to this day.
Today on the show, we'll hear from a scientist who's been working with children with congenital Zika syndrome since the outbreak. And we'll also talk with a journalist who has been in communication with some families who are feeling left behind. But let's start with Zika virus itself. Although it wasn't on most people's radars until 2015, it was actually discovered way back in 1947 in a monkey living in the Zika forest in Uganda. And for decades, it was considered pretty non-threatening, especially when you look at other mosquito-transmitted viruses like West Nile, yellow fever, and dengue. For comparison, dengue hemorrhagic fever killed hundreds of people in Brazil every year.
The first known Zika virus epidemic was in 2007 on the islands of Yap in the Western Pacific. All reported illnesses were mild. Then in 2013, an epidemic broke out across the French Polynesian Islands with more than 30,000 cases, some of which caused neurological complications, including Guillain-Barré syndrome, a rare disorder where your body's immune system attacks your nerves, causing weakness and tingling that can spread and lead to total paralysis.
A retrospective study a few years later also found an unusual increase in brain malformations and severe microcephaly in fetuses and newborns following the epidemic. But it wasn't immediately noticed at the time. Zika continued to spread from there, reaching Brazil in 2015, the first time it was documented in the Americas. And then it spread to many more countries, including the US.
So, when doctors started noticing all of these babies with microcephaly, they were, of course, alarmed and started looking for answers. They needed to figure out what could have caused it. They talked with the mothers of those babies to see if there might be something that they all had in common. And many of the mothers reported having a skin rash when they were pregnant. Remember, a skin rash was already known to be a common symptom of Zika virus. Then, a doctor collected amniotic fluid from women who were still pregnant, whose babies had just been diagnosed with microcephaly in the womb. And the doctor found Zika virus in that amniotic fluid, which meant that it was able to cross the placenta, to go from mom to baby. And these were the first bits of evidence linking Zika to microcephaly.
By May 2016, scientists had collected enough data to confirm that Zika could cause microcephaly and that it was neurotropic, meaning it preferentially attacked the nervous system. And by 2017, Congenital Zika syndrome had been characterized to include brain, hearing, and eye abnormalities beyond microcephaly. Some infants exposed to Zika in utero are born with an average head size, but then begin displaying serious cognitive deficiencies and motor impairments as they grow up. Many need wheelchairs and have difficulty swallowing, so they need help eating. They're also prone to epileptic seizures. How Zika causes all of these neurological problems still isn't fully understood. There have been studies showing that Zika can evade your immune system and that it can infect and mess with neural progenitor cells, which give rise to many of the cells in your brain and spinal cord.
Zika virus is mainly transmitted to humans by mosquitoes, but it can also, of course, be transmitted from mom to fetus, as well as through sexual intercourse and blood transfusions. And there's no vaccine or clinically approved drug to treat Zika. So, Deboki, do you remember when you last heard about Zika?
Honestly, I don't really know. It must be like at least a few years since I've heard it talked about like a lot. And since then, I think I've only heard it come up in the context of travel warnings for pregnant people.
Yeah, I think the last time I really heard about Zika was in reference to the 2016 Summer Olympics that were in Rio de Janeiro, Brazil. And sort of, the post-Olympics look back and, hearing that US athletes didn't seem to get infected, because I know that that was a major concern going into the Olympics. I'll be honest, I hadn't thought about it that much since maybe 2017. And then, especially with COVID, it just wasn't on my mind. But then, as you know, Jaboki, I came across a story late last year in Undark magazine. It was by a science journalist from Brazil named Mariana Lenaro. She's currently based in the US, but she was living in Sao Paulo, Brazil back in 2015. So we called up Mariana, and she told us a bit about her experience being in Brazil at the start of the outbreak.
The media started covering that immediately, and the images we saw on TV were of these waiting rooms in children's hospitals with all of these children with a smaller head. So it was really shocking to see. Everyone was just scared. It was like the atmosphere was of kind of panic. Women who were getting pregnant were very worried. People were started delaying pregnancy plans because of this.
Mariana told us that during the initial months of the surge in microcephaly cases, she was almost exclusively covering Zika. It was all she was writing about. And then in 2017, she moved to New York to do her master's in science journalism at Columbia University. At the end of the program, she had to write a thesis and chose to do hers on Zika.
So at that time, it had already been kind of forgotten by the mainstream media. And at that time, I had the chance to actually go to Recife in the state of Pernambuco, which was one of the most affected places, and actually talk to these mothers and talk to these doctors who were the first ones to observe that surge. And that was when I had like the chance to see with my own eyes what these families were going through. Some of them were more impacted than others. And then these mothers were saying to me that they had the impression that when this first started, there was a very intense media attention on them. Several researchers were going after them to ask them to participate in clinical trials. And at that time in 2017, they were already feeling kind of abandoned, like all this attention happened, but nothing came from it. Like, we're here, we still don't have proper access to all the multidisciplinary care that our children need. So that kind of stuck with me.
Then last year, in 2021, Mariana received a fellowship that would allow her to explore those conversations further. She hadn't been able to stop thinking about the Brazilian families of children with microcephaly who she'd met a few years before, and how the COVID-19 pandemic may be affecting them.
When everything closed up because of COVID, I thought, what happened to those children? Are they staying home? Are they not going to these therapies that they need so much?
Mariana contacted some of the families, and as she began to interview them, the initial focus of her story shifted from the impact of COVID-19 to other experiences that left these families feeling forgotten, namely participating in clinical trials in Brazil, but not having scientists and physicians follow up. She told us the story of one of the mothers she interviewed, who's actually the head of an association for families of children affected by Zika in Midwest Brazil.
Her daughter has microcephaly, and she participated in a clinical trial, and she had to go to the hospital multiple times to be tested for this trial. And then after a few months the tests had ended, she saw on a social media post her daughter's doctor saying that the article with the results of that trial had been published by a scientific journal. And then she reached out to him to saying that she wanted to be informed of the results, if he could send her the article. And then what he told her was that the article could not be publicly shared because it wasn't an open journal, and that it was in English, so she would probably not understand it anyway. And she felt deeply disappointed with that response. She felt she was being underestimated. She felt she had been used because she had gone through all that trouble so that her daughter could participate in the trial, hoping that the study would find something that could help her and other children with the same condition, or learn something to maybe be implemented in the future.
I can only imagine how upsetting it would be for a parent of a child who has put so much hope into a clinical trial and then sort of felt like they were just left in the dark. But this story and other stories are way more complicated than this person was bad or this person was good. Mariana told us that she talked to not just these mothers who felt left behind, but also clinicians and scientists, and it became clear that this scramble to get research and clinical trials going at the start of the outbreak began with good intentions, but it led to a lot of miscommunication.
Here's Mariana talking about her experience speaking with some of the scientists involved with the clinical trials.
All of these scientists had really good intentions, and they were under a lot of pressure when they started seeing these cases of microcephaly, and they had to act really fast to investigate what was happening. In hindsight, some of them, when I introduced the topic of the story, they immediately recognized that they were aware of how these mothers were feeling, and they felt they needed to do a better job in communicating with them. But they also faced many challenges. One of them is just being able to translate complex topics to a general public. Some of these scientists are not trained to do that. They have a hard time doing it. And other challenges are sometimes they were involved in research projects with universities in other countries, and they had to wait for analysis to be made, which took a lot of time. And so this feedback to the families would take longer than they wanted to. A couple of researchers who I spoke with kind of disagreed with the premise of the stories. They felt that they had done their best to communicate with these families, and they say that they never promised they would tell them the results in details and proactively contact them to tell them the results. And they were kind of just learning now that maybe these families had different expectations. And some of the people I talked to, even after I explained what these mothers were saying, they still didn't quite understand the problem. Like they think that's just how research is done. This is just how things are done.
So let's take just a few minutes to talk about that, how this kind of research is done. Clinical research is essential research. It's what allows scientists to develop new, safe treatments for diseases and even prevent the spread of disease. Think about COVID-19. Without clinical trials, we wouldn't have had those vaccines.
And it should go without saying that doing clinical research ethically is just as important as the research itself. Ethical research means protecting the safety of people who volunteer to participate and preventing them from being exploited or treated unfairly.
Participants have to know what they are doing. So there is a whole process of informed consent. Many people think that it's just signing a form. That's not the informed consent. It is a process where you have to really inform the participants and see if there are doubts, if the people understand exactly what you're saying, and then if they can enter that voluntarily.
That's Florencia Luna, who's based in Argentina. She's the director of the program of bioethics at Flaxo, the Latin American University of Social Sciences, and the principal researcher at CONICET, the National Scientific and Technological Research Council in Argentina. Like Florencia said, people should be fully informed of what these trials are asking of them and enter them on their own accord. But even that can get complicated depending on the person's situation.
In many circumstances, when you do not have any treatment or your hospitals have very scarce resources, maybe participating in a research is the way to get access to medicines. And then you may ask yourself, well, how much freedom does that person has to refuse if there's no other possibility? So it is quite complex, the field of research ethics. There are trials that are quite simple and there are no major problems, but there are others that pose a lot of challenges, ethical challenges.
Although there were plenty of mothers of children with chronic Zika syndrome who Mariana spoke with that did feel used and left behind by the clinical trials they signed up for, not all of the families felt that way.
One of the mothers I spoke to, she had twins where one of the children had microcephaly and the other didn't have microcephaly. And she participated in a study looking specifically into twins to find out what could be leading one child to have microcephaly and the other not having microcephaly. Whenever she needed something from the scientists, they would respond to her. They would provide any information that she needed. Because these families, sometimes they have to prove that their child's disability is due to Zika, because children who had microcephaly due to Zika, they received some social benefits that are exclusive to them. So these scientists would provide this documentation proving that they had microcephaly due to Zika. So that was helpful to her. And the scientists leading that project also recommended a very good neurologist that helped her child when she needed. So not all of the people participating in those studies had negative experiences with scientists.
We talked with a scientist who's had a very positive experience working with these families over the last 5 years. Camila Ventura is an ophthalmologist and researcher, currently the head of the Department of Clinical Research at the Altino Ventura Foundation, a nonprofit in Brazil. Camila is committed to eradicating healthcare disparities through her work on congenital Zika syndrome. In 2015, she was one of the first doctors to witness the eye damage caused by Zika.
I was examining these babies, and there were a few, at that time, maybe a couple, that had severe microcephaly. And the nurse said, can you please screen these babies? We don't know what they have. We already ruled out our well-known congenital infections, and we don't know what this is. I went and I examined, and I saw these lesions in one of these children's eye. And I said, this is so different from what I know. I don't know this. So I was very interested in finding more about this.
That same week, she received a call from neuropediatrician Vanessa van der Linden. At the start of the Zika outbreak, Vanessa was seeing babies born with brains that were much smaller than average, but that also had fewer folds. The squiggles that you typically see all over the brain, those weren't there, or there were far fewer of them. Vanessa called up the Altino Ventura Foundation, wondering if Zika was affecting the eyes. Camila told us that because the eyes are an extension of the brain, diseases that impact the brain also often affect the eyes.
Within 2 days, they'd examined 80 children with microcephaly and found that many had eye issues. From there, Camila and her fellow researchers at the Altino Ventura Foundation teamed up with psychologist Ann Wheeler and her colleagues at Research Triangle Institute, or RTI International, based in North Carolina. They received grant money for a 5-year project to study the neurodevelopment of children with congenital Zika syndrome over that time. The families come in 4 times per year. 2 of those visits are focused on the caregivers, who are asked about their physical and mental health and if they're feeling supported by their community. The other 2 visits are focused on the children, who go through an extensive assessment.
We see their motor skills, we see how they're doing with their language, communication, their receptive communication as well. Are they understanding what is happening around them? Do they recognize their parents, like when their mom calls on them? And also their clinical aspects. Are they having seizures still? It was very hard initially to control these seizures. And now we see most of them controlled, of course, but some of them are still not under control and taking different medications. So we are also asking about that.
Camila told us that about 1/3 of children with congenital Zika syndrome have an ocular lesion, a clump of cells on the backs of their eyes. And over 95% of those children have a visual impairment.
So they are not seeing correctly. Of course, we are providing them with glasses, but despite all of this, they still cannot see what another child their age can see because their brain is damaged, right? So we understand that the eye is like a camera and is capturing the information from around us. And what is processing the camera's image is the brain. So regardless of having structural damage on the eye, these children cannot see properly because their brain is damaged.
By doing all of these studies, they're able to understand more about what the virus does. But they're also able to provide interventions that will hopefully reduce the burden on these families.
We were trying to understand how these children were affected, but not only them. We wanted to include the families because we understand that there is a huge burden on these families. They were not expecting to have a child with any deformities. Many of them found out about these deformities when the child was born at the maternity hospital. We understand that the main caregiver, that are mostly mothers, they are feeling by now depressed, anxious, and this has a lot to do with the changes that they went through because of their child, right? Also, when a mother is having to deal so much with that child that needs so much attention, siblings around them feel forgotten. So we also analyze those different aspects of the family, how the family was affected.
Camila told us that although the Altino Ventura Foundation's partnership with RTI International and the NIH will continue, the grant they have is now, 5 years later, coming to a close. So they're looking for additional opportunities that will allow them to continue working with these children and their families.
We are now open to finding new partners and applying to new grants to continue helping these children. We feel responsible, co-responsible for these children. I feel committed and I do want to keep on helping and I don't want to let go. So we are really trying to figure out how to maintain the assistance, the medical, clinical, and also the social part of it, because it's so important to provide them with dignity, right? We want them to feel that they belong to our community, that they belong to this world. These children, they are so vulnerable and they are really in a situation where it's hard, it's emotional, right? I feel like they're my children, they're not. Ah, you get attached.
Hearing Camila talk about this, I mean, the interview that we did, it was over video. So, you could see how emotional she was about all this. But I'm sure as a listener, you can still hear it in her voice. This to me it's an example of a scientist and a team of scientists that really are thinking about the patients and their families for many years. So for parents in a situation where they really can't win, knowing that they have people like Camila in their corner must feel huge. And I really, really hope that they get the funding they need to keep this important work going.
So before we close out this episode, let's talk about a few more things. Mainly, why poor communities in Brazil were hit the hardest, why the number of Zika cases has gone down since 2016, and at least one idea to stop the spread of Zika. All right, Sam, let's start with the communities. Why were poorer communities being hit the hardest?
Well, like with many diseases, a lot of it comes down to infrastructure. In the case of diseases like typhoid, which we talked about in a previous Tiny Matters episode, not having access to clean water means a greater risk for being exposed to the bacterium that causes typhoid. With Zika, you're not getting it from the water or the air, you're typically getting it from mosquitoes. So if you live in a building without screens on the windows or an air conditioner to keep things cool while you close your windows at night, you are more likely to be bitten by mosquitoes, and some of those mosquitoes might carry Zika. And in poorer places where trash pickup is less reliable, water might pool in uncollected trash. Mosquitoes breed in water. Rainwater damage can also lead to pooling water that's in or around homes. And if sewage doesn't flow to a septic tank or a treatment plant and instead pools in a backyard or an alleyway, mosquitoes aren't that picky. They will breed in wastewater too.
So now let's talk about why Zika seemed to disappear. I mean, first of all, it hasn't actually disappeared. In 2020, Brazil reported over 15,000 cases, but in 2016, it was over 205,000. So it's much more accurate to ask, why the dramatic decrease in cases? Well, it could be for a variety of reasons, but a lot of experts say it's due to, in part, herd immunity. Because so many people in Brazil were infected in 2015 and 2016, a lot of people there could now be immune to Zika. How long that immunity will last, though, isn't clear. And recently, a group of scientists published a study on Zika that showed how the virus could evolve and mutate to become more dangerous. And like with any virus, in the case that Zika does mutate, that could mean people currently immune to it no longer are. I guess what I'm saying is that there are a lot of question marks here.
So, where does that leave us? Well, definitely in need of more research to understand this virus better, and hopefully one day come up with a vaccine to prevent people from getting infected. But in the meantime, there are a lot of scientists focused on what's spreading Zika. By that I mean mosquitoes.
In May 2021, after a decade of fighting for regulatory approval, the first genetically modified mosquitoes were released in the Florida Keys. The goal in releasing them was to suppress populations of a certain species of mosquito that's known to carry a bunch of diseases, including Zika. The genetically modified mosquitoes are all male, and when they mate with females in the wild, they pass on a gene that will kill any of their female progeny while they're still in the larval stage, ultimately reducing the overall mosquito population. But why just female progeny? Well, because only female mosquitoes actually suck your blood and pass on disease.
Which I did not know before researching this episode.
It's fair that you did not know that. I have had to spend some time learning about mosquitoes, and honestly, if I didn't hate them so much based on my own personal experience getting bitten a lot, I would probably find them kind of fascinating. we should say that there are some people who are not a fan of this kind of approach because of the potential impact of having fewer mosquitoes in the ecosystem. There are, for example, birds that like to eat mosquitoes. So if you kill off all of these mosquitoes, you're potentially reducing how much these birds have to eat. But just a couple months ago, the same company got the green light to release another 2 million of these mosquitoes in both Florida and California.
It'll be interesting to see if this kind of approach really works. And I'm not going to say if I'm like super pro or con because I really want to see the data first, but I will say that this is an alternative to insecticides, which are still used a lot and some of which are definitely not good for us. Plus, the massive amount of insecticide that's used to control insects in the US has led to mosquitoes that have evolved to become resistant to them, kind of like antibiotic resistance, but mosquitoes, which, maybe that would be a cool episode. So who knows? But for today, that's a wrap on Zika virus, which means it's time for the 60-second science show and tell. If this is your first time listening or you didn't listen to the previous episode, the 60-second science show and tell is really an opportunity for Deboki and I to each get 60 seconds to share something, whether it's science news or just like a weird tidbit that we learned. Who wants to go first? Do you want to go first? Do you want me to go first?
I can go first. I'll go first this time. I think I made you go first last time and did not give you any choice at all on the matter. So.
Okay. Ready? Go.
So today I am sharing an article that I read and that I read like a few weeks ago, and it's just really stuck with me and it felt really relevant to the topic of our episode today. And the article is called The Pregnancy Gap by Jennifer Cousin-Frankel. It's a news article in Science. So Science is a journal, but this is not like a journal article. It's geared towards a public audience. And like I said, I've had it on my mind for a few weeks now, and it's about how hard it is to navigate what medications are safe to take when you're pregnant and what kind of effort is being put in towards developing studies that will hopefully make it easier for people to make choices about what's best for them and their fetus. And, it's just really stuck with me because I think one of the weird things about pregnancy to me, like when I think about it just like as an abstraction, is that it's so common, but there's so many things about it that are really uncertain and really hard to navigate in terms of the choices and risks that are built into it, just because we don't actually even know that much about it, again, despite how common it is. And so, studying pregnancy is super fraught because, it's pregnancy. There's this like child that is hopefully going to come out of it at the end. So studying these things it's really difficult. So I really appreciated this article and I would recommend reading it if you are curious about kind of what makes it so fraught and how people are thinking about trying to overcome those challenges.
That's so interesting. And it's so true, right? It's like something that's, of course, so commonplace in a sense, like all of us are here because it happened, right?
Yeah. I think about that all the time. It's like every single one of us is a proof that pregnancy has happened.
Right. But when, we could go into it, but the more that you look at sort of like pregnancy research or sort of the lack thereof and the lack of understanding, it's very obvious that certain things were not maybe prioritized by the scientific community for a very long time and still aren't necessarily, but at least, with articles like this and things that are more geared towards the general public's understanding, hopefully we'll reach a point where people are asking more of these questions. And that requires funding to answer some of these questions.
Yeah. It's like when I was like thinking about, what we were talking about today, like Zika and like, these women who are trying to navigate what's right for their child and trying to understand, what these studies have told them, these studies that have involved them and their families. I feel like that's what, like, it reminded me so much of this article because so much of it is about like agency and like having agency over your body, having agency over the information that people get from your body and like trying to just understand what are the choices that are out there. Being a parent is so loaded with all of these these expectations, but also like people are very open about judging parents about the choices they make. But it's because we're all making choices in a really imperfect system of like, we don't know.
Yeah.
we just, it's so hard to figure out. So yeah.
Well, thanks for sharing, Deboki. That's very interesting. And I'm definitely going to read that article. So I guess I'm up.
Yes, it is your turn.
Okay. Do you want to count me down, I guess?
Yes. Ready, set, go.
Okay. So I'm going to talk about something completely unrelated to the Zika episode, something just a little out there that I thought was kind of cool. My 60-second science show and tell this week is about a species of gecko versus venomous scorpions. So geckos typically are not known for being super fast or ferocious, and they kind of, typically when they feed, they'll do this sort of lunge and grab and chomp. But apparently for this species, when it comes to scorpions, it's a whole different story. So they do this thing called shake feeding, where they will bite the scorpion and then thrash around and slam it into the ground. And this is not something that geckos are known to do. And it's very specific. And so, other animals will use thrash feeding. So I didn't know this either, but dolphins apparently thrash feed when they eat octopuses. They'll whip them around and then throw them up in the air and then eat them. Very depressing. Sorry. I love octopuses, but it is what it is.
So the thing they're doing is they're shaking it around and eating it?
Yeah. Yeah. They're thrashing it around to kill it and then eating it.
What if they're making a scorpion smoothie?
I know, right? Yeah, it's pretty intense. The animal kingdom is ruthless, is what I'm saying.
Do you know if there are any videos of this? I want to look it up now. Dramatic slow motion video. Good. I only want dramatic slow motion video. I am watching a video of this happening. There's a scorpion chilling until a gecko just launches at it and it's just wildly shaking its head back and forth. It was so fast.
Yeah.
I did not realize it was going to be so fast. Oh, man. I'm never going to look at geckos the same way. Wow.
I know.
That's violent. I know. Wow. Well, that was incredible. Thank you. That was very cool.
I mean, it's quite the departure from the episode, but maybe, we're getting a whole range of things. You just never know what you're going to get in our science show and tell.
It's true. That's the point.
If you want to read the stories that Deboki and I talked about, we've left links to those in the episode description. Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society. I'm your exec producer and host, and I am joined by my co-host, Deboki Chakravarti.
This week's script was written by Sam, edited by me and Ruben Rodriguez-Perez, and fact-checked by Michelle Boucher. The Tiny Matters theme and episode sound design are by Michael Simonelli, and our artwork is created by Derek Bressler. Thanks to Mariana Lenaro, Florencia Luna, and Camila Ventura for chatting with us.
And if there are some tiny things that you think matter and that you would love us to explore in a future episode, please shoot us an email at tinymatters@acs.org.
We'll see you next time.